Okay. Um, so today is slide 4, and we will talk about, we will shortly recap the correlation coefficient concept of, how you can sort of find the strength for, find the linear strength between two variables, and then we will go over some probability, some basic probability kind of things. Okay. So yeah, reiterate correlation and then see introduce basic probability concepts. And we will do some questions with probability, and deal with some probability distribution and deal with some contingency tables, two-way tables as well. Okay. So again, a short recap on correlation. Um, the correlation coefficient R tells you the strength of the linear relationship. So if given two variables like this, so this is variable, so let's say salary is variable 1, this is variable 2, it gives you uh, this line sort of gives you what is the linear relationship between these two variables. And what you need for this is you need R, right? You need correlation coefficient to sort of assess the linear relationship between the two variables. And then we see that for this graph, things it looks linear, right? There's a linear trend. It's positive linear with the R value of probably around like 0.7 or something. Look at this example. So we have wine consumed as your explanatory variable, as your explanatory, your independent variable. And then you have on the y-axis, you have your response variable. Or your dependent variable. So so these things that go on the x-axis and the variable that goes on the y-axis, they have their names. Okay, the names are explanatory variable or independent variable for the variable that goes on the x-axis, and the response variable or dependent variable. Um, these names are pretty intuitive. Explanatory means that wine consumed is explaining your heart disease deaths. So this is your response, and this is your explanatory, and this all falls under scatter plot. Yeah. Okay, any questions about this? Yeah. So what sort of a relationship do you see here between these two variables? Like, so what is the relationship? Positive, negative, negative, right? And what will be R value for this? What will be a tentative R value? Less than 1. So R, so the whole R is from -1 to +1. Okay. So if you have -1, it means perfect negative linear relationship. Perfect negative linear relationship. And if you have 1, then it means perfect positive linear relationship, right? So Where do you think this scatter plot R's might be? Somewhere here, right? Maybe. Yeah, but it's not -1 because it's not perfect, right? But it'll definitely be below 0. Um, 0 means no linear relationship, so it's all scattered all over the place. Okay, so this makes sense, right? So always scatter plot is for two variables. Remember the name, what each of the variables are called. Depends on what goes on the x-axis and what goes on the y-axis, and you have this R that sort of quantifies the strength of your linear relationship. It tells you how strong your linear relationship is, and in what direction, in positive or negative direction. Yeah. So these are all the things that I just said. The correlation coefficient R is a number that tells you how strong a relationship is. The number always lies between 1 and -1, -1 and 1. -1 means strong negative relationship, 1 means positive, and 0 means no relationship. Okay. And you have here three examples: uh, positively correlated, no correlation, no linear relationship, and negatively related. Okay. Is this clear? Yeah. This is the mathematical formula you need to calculate R, but I don't think any questions will involve you using this formula. As long as you know, as long as you know these things, I think you all should be good. Uh, as long as you know what R is about, what the names of the two variables are, and what sort of, if given multiple scatter plots, you can identify which R it corresponds to, then it should be good. Okay, but this is the mathematical formula. Um, what you have is, let's say you have variable 1, and you have variable 2. Let's say speed, heart rate. Let's say you have a data set like this. Okay, you have speed as in how fast a person runs, and you have their heart rate, right? So how will you draw a scatter plot like this? So what would you put on the so what would you put on the x-axis, and what would you put on the y-axis? Okay, and why do you think so? True, true. So the running speed is your explanatory variable, right? It is explaining your change in the heart rate. Um, and it makes us sense to do it like this. So whenever given two sort of data sets, and you have to decide what makes sense to choose which one as the explanatory and which one as the response. Okay, so this is the explanatory. It is explaining the change in heart rate, and this is the response. Okay, this is also called the dependent. Dependent as in it is, this heart rate is dependent on running speed, and this is also called independent. Okay, dependent. And what sort of a R will you sort of guess for this? Positive, right? because as running speed increases, we guess that heart rate will go up. So your data points will look like this, somewhere like something like this. So for this running speed, this is your heart rate. As the running speed is increasing, you'll see that the heart rates are also increasing. So this one dot is both running speed and heart rate. Okay, so it's sometimes good to like dive into the details so it's clear. Um, and it'll have a positive R greater than 0. Um, okay, so questions like this, as long as you're comfortable doing these kind of things, uh, I think we should be good with correlation coefficient. The another important sort of point is that it only measures the linear association between two variables. So so if I give you a plot like this, I think we've discussed this. Let's say you have a plot like this, okay? Um, what 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 sort of relationship is there? R might be equal to 0, but what I'm asking you is there any relationship between speed and heart rate? The first question, okay, is there any relationship between speed and heart rate based on this plot? Yeah, yeah, it's just not linear, but there is a relationship, right? So this people confuse that in exams. So when asked if there's a relationship, yes, there is like a curvy. I think there are examples in your slide that has this, like a curvy linear, like a exponential kind of relationship, right? But there is no linear relationship. Okay, there is a relationship. There's not. It's just not linear. It's a different kind of relationship. Okay, and your R will probably be 0. Your R is only for linear relationship. So if you measure R here, your R will be close to 0. Okay, is that clear? Yeah. And R does not change when we change the units of measurements. Okay, what I mean by that is, um, if speed is in um, kilometer per hour and heart rate is in, what is the unit of heart rate? Beats per minute. Okay, let's say BPM. Then you change the scale. Okay, you change the speed to now meter per second and heart rate to beats per second. Okay, the R does not change across these two. Even when you change the units, change the units of measurements of XY. XY means this is X and this is Y. Even if you change the units, the R still does not change. So that's important. Okay. Um, you know, you change the units here, change the units in both, the data set shifts consistently. Okay. Um, is this clear? Yeah. More examples. R here is 0.4. 0.4 means not a linear, not a good linear relationship. Yeah. It's pretty linear actually. Here, this is 0. So, any questions about scatter plots? Yes. Yeah. I think, yeah, yeah. So whenever you see how to explain this? So does the outlier affect the mean? Yes, right. So mean is something that is not resistant to outliers. Whenever you have outliers, mean changes drastically. Um, and I was giving this example of, when you have, how can I back out of this? Oh, uh, I always give this example of, when you have a data set like 1, 2, 3, 4, 5, right? What is your mean? What is the mean of this data set? 3.5, right? And let me introduce now our outlier. Now, your data is 1, 2, 3, 4, 5. And then you have an unusual 100, which is an outlier, right? So what is the mean now? Probably, I mean, you can calculate it, but gonna be it's gonna be like 17, 20, something like that. It's affected by outlier, right? So so any formula you see where it has mean in it, uh, it means that that quantity will be affected by outliers. For example, is standard deviation affected by outliers? Yes or no? And do you guys know the formula for standard deviation? And this is the mean, right? If you see that in the form, I mean, this is might be a different formula than what you have in the slides, but let me see if I can find a. Probably you have this one, right? So you see that the standard deviation calculation involves mean in it. So So if there is outliers in your data, then standard deviation is also affected by outliers because it has mean. It involves calculating mean in it. And the same goes for this. It has mean. We use mean to calculate the correlation coefficient. So whenever you have outliers, your mean will be drastically affected, and so will all the other quantities like standard deviation and R that depends on mean. Does that make sense? Yeah. And you see that this formula has mean in it, right? We use mean to calculate the R. So this will be affected by outliers, and so will the standard deviation, and so will all the other things that has mean in it. Okay. Yes. I don't think so. But you might want to check with your professor for that. So so that is all about scatter plots and the correlation coefficient and all of the important things you guys need to know. Now let's do some probability questions. Okay. Um, I mean, probability is, teaching probability from ground up is will take an entire class. So we're just gonna do some examples, hoping that you guys have already started probability right in classes. Okay. So how do you the first question? Let me zoom in. Sorry. Oh, okay. Thank you, Martinez. I just saw your message. Okay. Uh, okay. Yeah. First question. Stat 201 instructor is selecting questions from the pool of questions. Pool contains 10 questions from chapter 1, 5 questions from chapter 2, 20 from chapter 3, and 15 from chapter 4. Each question has an equal chance of being selected at random. What is the probability that a question from chapter 3 is selected? That'll be the probability, right? So the probability is 20 out of how many questions there are in total. So 10 from chapter 1, 5 from chapter 2, 20, and 15. Sorry, the the bot. So 2 out of 5, right? So every 2 out of 5 questions is going to be from chapter 3. Um, so why did we do this? Um, this is sort of a general formula for calculating probability. Okay, probability of any event is just this fraction of how many times that particular event occurred divided by the total number of all events that are in considerations. Okay, so same idea goes for this. So probability of picking a question from so what is the event here? It's picking a question from chapter 3, right? Chapter 3, this is the number of questions in chapter 3 divided by the total number of questions. And this was 20 over 50 or 2 over 5, right? This is the basic frequency interpretation of probability, where you just count the number of event and you count the total number of things and you divide it and you get the probability. Okay. What about this? Can you guys see this? Yeah. Uh, yeah. So given this question, we have to find these three things. Okay. There are 50 students in a class. 15 are engineering, 20 social, and 50 linguistics. E is the event that a student is an engineer. S is the student is a social scientist, and L is the event that the student is linguistic. So let's do the first one. What is the probability of E? What is the probability that if you pick randomly a student in this class, that student is going to be a linguistic student? So just 15 over 50, right? 3 over 10? Yeah. Um, so every 3 out of 10 students is going to be a engineering student. Okay. So this is the first question. It's pretty simple. What is the second one? E or L? So what does OR mean here in terms of event operations? What does OR mean? Union, intersection, union, right? E union L. And what is the formula for this? So in terms of if A and B are events, you do it like that. So for this, it's E plus probability of L minus probability of E and L, right? So can we solve for this? So do we know P of E? Yes, right. So 3 out of 10. And what is P of L? Um, yes, so there are 15 linguistic students, so the same thing. What is the probability that they can they can they can be what is this probability? E intersection L. Why do you think it's 3 or 5? How do you get that? So what am I asking when I ask you the probability of this thing? Can you think of that? Yeah. So when if you have 50 students and I ask somebody, go and pick a student that is uh both what engineer and linguistic, right? Is that possible for this case? No, right? Because all the 50 subjects, they are separated out by majors. There is not a student that is um both engineer and both linguist at the same time. There could be, but not in this example. Okay, so we can say that 0. So just 6 over 10. Um, and they are called mutually exclusive events. Okay. What does mutually exclusive means is that two events cannot occur together at the same time. Okay. So what will be an example of mutually exclusive event is when you pick a card from a deck of cards, you cannot pick a card with a heart and a spade at the same time, right? So the two events are mutually exclusive. Um, so whenever two events are mutually exclusive, their their probability intersection is 0. Probability of event A and event B happening at the same time is 0. Okay. Is this clear? So we're just using, so we have to find this. We notice that this is this, and we have this formula for union. We notice that the last one is mutually exclusive, and we did this. And there are many ways you can get to the answer in probability, right? You don't have to follow this setup. You can use a different set of formulas, and not a different set of formulas. You can, get to the same answer with a different approach. Okay. So what about ENS? What about, yes? Yeah, yeah. If both events are exclusive, then your intersection probability is 0. So you don't have to find. You just set it to 0, right? So yeah, you first have to sort of read the question to see if things can be mutually exclusive or not. Um, So what about the last one? It will also be 0, right? Unless uh, specified in the question that there can be both majors, we are assuming that there are none. So this and this. Okay. Any questions about this question? Um, Another question involving deck of cards. So a standard deck of cards has 52 cards in them. Each card has two attributes. So it has a rank and it has a suit. The rank can be out of these 13 possibilities, right? 2, 3, 4, 5, 6, 7, queen, jack, king, ace. While the color or the suit can be 4. Okay, so once you know this basic information about cards, you can solve these sort of probability questions. Okay, and I sort of suggest that you remember this because if a question is asked in the exam, then you will not have this information. Okay, I don't know if they're gonna ask you or not, but usually what I see is they just ask you directly, um, assuming that you know this part. So what about this one? What is how do you solve the first question? Um, Probability. What is the first one? Probability of drawing a heart. Let's see. Okay, drawing a heart. So what would be so what would be the general formula? The number of what? Hearts, right? In a deck of cards, and then divided by the total number of cards. So how many hearts are in a deck of cards? Yeah, all of the cards have 52, and every number has each of these four suits. Okay, so how many hearts? 13 hearts, right? Oh, so 13 out of the total number of cards, 52, whatever this probability is. Wow, thank you. Um, so every fourth card you draw, one of them will be um, a heart, right? Next one, what is the probability of drawing a 2, 3, 4, or 5? So let me write that. This is 1, this is 2. You can see my handwriting, right? And I don't know why that is shaking. What is 2, 3, 4, or 5? How do you get this? So it's like this is like saying probability of A. How do you write this? So let me. It's saying probability of 2. So what is the event we are interested in? First, let me ask you that. So in the first question, the event was drawing a heart, right? So what is this event that, and we wanted to find out what was that probability of drawing a heart. What about this one? What is the event? Or, right? So not and, or. So probability of 2 or 3 or 4 or 5. And how do you represent this in terms of event? What is or replaced by? Union, right? 5. Um, and you can, so what is the formula? What was the form? Yeah, you and that will be 0, right? So what is the, no, I was, so that you guys can see the formula. Right? So it's based on this. So here in the general formula, we only have two events. So that's why it's probability of A plus probability of B minus whatever probability of both, right? Now we have 4 events. So the formula still holds, okay? It's the probability of each individual thing minus the probability of all the things intersection. Okay, does that make sense? Yeah. And this is 0, right? Because you cannot draw all of these cards at a single draw. And then then you can do this. It's 2 out of, what is this? Probability of drawing a 2 is, how many 2s are there in a deck of cards? 4. Then 4s and 5. 4 each. So just 4 out of. And this is, this is 8, 16. Yeah, 16 out of 52. Yeah. This makes sense, right? We are just using this. So first you need to realize that this is a union question. And then you need to realize that you can use the same formula. Just the only difference is here there are 2 events in B. Now we have 4 events. Sorry. What about the last question? How many king of clubs are there in a deck of cards? 1, right? So the probability of drawing this is just 1 out of 52. Yeah. Yeah. This one? Okay. Oh, 4 out of 13. Okay. 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 Yeah, but I mean, as long as you know how to get to the answer, you guys can use the calculator, right? So, uh, so so that was about probability. With probability comes probability distributions, and they are a bit tricky to sort of understand at first. So, what do I mean by probability distribution, right? So, let's say this is we are working with the variable height, okay, and the height variable has this distribution. This is an example of a probability distribution. Okay. What is the probability distribution? Shape of this distribution. The shape is pretty familiar, right? The shape is called what? Bell-shaped, Gaussian, normal. So it's called a normal distribution, okay? Or bell-shaped or Gaussian. I mean, it has like 5 different names. So, but the question is, what do you understand when you see a plot like this? Um, oh, I cannot. You can think of the height as the probability. Okay. So what does the probability distribution tell you is that is gives you sort of a probability for each possible value of a variable. Okay, for example, height, right? If you say that height is, if you say that height, your data set follows a normal distribution with some mean and some standard deviation. So this is the mean, this is the standard deviation. Then it means that this is the probability distribution for height. Okay. And what it means is, I don't know if you can visualize this, if you can sort of feel this graph or not. So which height has the highest possibility or highest probability? The frequency is the highest, right? Or frequency is also called probability, right? So you see how, if there were like 10 engineering students, 10 out of that was the probability for engineering students. So frequency and probability have a one-to-one relationship. So these heights, you can think of these as the probability, right? So which value has the highest probability? This one, right? And this is the mean, right? And the as you go away from the center, what's happening is your probability is decreasing, right? So let's say if the mean was at 5.5 and the this is 4.0 and this is 6.1, 6.5. If I randomly pick, um, let's say these are all actual people in a room, right? So all of these height, all of these possible values of height are actual people in a room. So if you go in and pick somebody, what will be the height of that person? According to this 5.5, right? But are you sure it's going to be 5.5? No, right? So so there so what so there this is like a subtle difference. Okay, so this gives you the probability of different possible things. But probability does not mean, it will happen in real life, right? So if the probability of, raining today is very high, but it might not still rain, right? The same goes here. If you go and sample one value out of this distribution, it is highly possible and probable that you'll get this. But you can also get somebody with the 4.0 feet height. You can also get somebody with a 6.5. But in general, the more people you sample, the more you'll see that their height is around this 5.5. Okay. So this is what it means. It gives you all of the different possibilities. So these are all of the different possibilities, and it gives you the probability for each of the possibility. Okay. Does that make sense? Yeah. Um, and this is what probability distribution is about. Okay. Um, what about, and this is not an easy concept to explain in like 5 minutes. So this is sort of what I can give you for now. But let me give another example. Let's say, what about this probability distribution? Now we're talking about weight, right? So imagine we have a bunch of subjects in a room and they have different weights. Let me say 100 pounds, one, 150 pounds, and then all the way up to 300 pounds. This is 150. Okay. So what about now when you go into the room? What is the value that you'll possibly see a lot of the times? Closer to 100, right? And why is that so? True. So it's decreasing, right? So this data set or these people in the room, they're lightweight kind of people, right? So that's what you kind of assess, right? Because most of the people are 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 like 100 pounds, right? And there are people that are heavy, but their probability is not that high, right? So, and this is a different distribution, and it tells a completely different story than this. Okay, so so depending on what sort of a data set you have to choose the right probability distribution that fits the data well. Okay, so you cannot fit if you have this kind of data, you cannot fit a normal distribution to it. Okay, that will give you errors, or that's not the right way to do data analysis. And if you have a exponential, this is like a exponential distribution, which we will probably don't need in class, but you just have to understand the feel of it. Okay, let me give you one more example. Uh, um, what do I call this? Um, Lottery. Let's say you have now in a room a bunch of people that you give random lottery numbers, right? So one of them is going to win the lottery at the end of the day. What sort of a distribution will you want here? So if you just think about this, what we were doing is that we were giving people with low weight higher probability, right? And the probability decreased like this. So that was the shape of our distribution. Here, it was a normal distribution. The probability was highest in the middle and it was drifting off. What about this? What if I do, let's say these lottery numbers are random, and then you start from 0 to all the way to 2000. Okay, that makes sense, right? And then if I do, what happens if I do this kind, if I do this here, what would be a problem? There is definitely a problem. And this is the probability, right? So probability density. True. But it's not the amount of lottery, it's the literal lottery number you have. Yeah. So based on that, what does it mean? True, true. If randomly by chance I have 0 as my lottery number, then my chance of winning are very high, right? And the people who have 2000 as their on their ticket, their chance of winning is very low. So 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 this is not a good fit for this kind of thing, right? So what will be a good fit? What do you want to theoretically do when you're giving a winner to these people? Completely random, right? So what is it? What does it mean by it in terms of probability? It should be equal, right? Everybody should have equal probability. right? So something like this, right? This makes sense, right? Every single lottery number have the same height. Okay, so it's not changing like it was changing for weight and for height. And this is called so let me delete the bars. So this is called a uniform distribution. Okay, so you guys get the idea, right? What a distribution does, it just tells you what shape your data assumes, right? So if it's a normal distribution, if it's exponential, so there are a bunch of distributions that we need to consider. Oops, here. So this is the normal, so we did the uniform distribution. Everybody has the same probability. We also did the exponential distribution. It's like this. Lower values have higher probability, and then it decreases as the values increases, right? So something like this. We also did the normal distribution. So we will do binomial distribution is another important thing, and then Bernoulli distribution is another portion. You don't have to know, but the shape is like this. So the only thing that is different between across these things are the shape, right? So and if you change the shape, you change the story of how you're doing things. So these things are important. Okay. Any questions? Any questions from Zoom? No? Okay. Okay. So I'm gonna end the Zoom session. Okay. Thank you for joining. Stop recording.